All right, so here is another example of a system of inequalities that needs to be graphed, and we're going to look for a solution. Okay, so for this specific question here, both of my inequalities are not in slope-intercept form, so I'm going to have to try to solve to get these guys into slope-intercept form, which is going to allow me to identify the slope and the y-intercept. Okay, which means essentially is that I want to solve these guys for y, right? Now, again, when I work through these questions, I always start off with one inequality at a time. So I'm going to solve the first one. I'm going to graph it, work through everything before I move on to the second one. Okay, so first up here, I've got 2x minus y is greater than 4. Okay, so I want to isolate the y. Now, there's a couple of different ways to do that. Okay, I'm going to, for now, keep the y on this side and just subtract 2x from both sides. Okay, I'm left with negative y, don't drop the negative, is greater than 4 minus 2x. Now, how do I get the negative? How do I get the y by itself? Is I got to get rid of this negative. There's two ways to think about it. Is either I can think about it as dividing by a -1 or multiplying both sides by -1, which is essentially the same thing. Okay, so I end up with y over here is -4 plus 2x. Is basically that negative just flipped all these signs, went from a +4 to a -4, a -2x to a +2x. But that one caveat that we can't make sure that we don't forget is I have to flip the sign when I multiply or divide by a negative. Now, what sign am I talking about? I'm referring to this greater than now changes to a less than. And that is a crucial step. If you don't do that, your graph's going to be wrong. Okay. But now that I've got this guy here, I'm going to go ahead and graph it. So again, identify my y-intercept is the constant term, my slope is the coefficient. So first start off at -4, 1, 2, 3, 4, and my slope up 2, right 1, up 2, right 1, up 2, right 1, and so on. 2, 1, 2, 1, 2, 1. Same thing in reverse. Down 2, left 1, down 2, left 1, down 2, left 1. Now again, before I plot my line, focus on the inequality. Okay, the fact that there's no line underneath tells me number one, it's dashed. Okay, so start here, and as I go, pick up your pen or your pencil to draw that line. Of course, we always add arrows at the end. Now it's an inequality, so I also have to talk about shading. Less than means that I'm going to shade below the line. So the trick here is pick any point on your line and go below, down. Oh, so I'm in this region here. And again, I like to draw these somewhat perpendicular lines to indicate my shading. Okay, try and be somewhat consistent. This could definitely be neater, but it gets the job done, right? Maybe add a couple of lines in between here. Does not have to be perfect. I've seen graphs that are way worse than this. Okay. Now, also, we label this. So this here is y is less than -4 plus 2x. Okay. Halfway done. Now, 2. Same idea is that now I've got x plus 3y is greater than 6. I want to solve this for y. 2 steps. Number 1. Okay, so I subtract x from both sides, and I end up with 3y is greater than 6 minus x. My last step is to divide both sides by 3. And I get y is greater than 2 minus x over 3. Okay, now this guy here is my y-intercept. This guy here is my slope. Okay, notice here that I did not flip the inequality sign like in the last example because I divided by a positive, not a negative, right? But my y-intercept is a +2. My slope is down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Same thing in reverse. Up 1, left 1, 2, 3. Up 1, left 1, 2, 3. Up 1, left 1, 2, 3. Now, again, before I graph this, take a look, and I see this here is going to be a dashed line, which means as I draw this, I'm going to lift my pen up so that I create this dashed effect. Arrows at the end to indicate it goes on forever. Label. And what did I forget to do? It's an inequality, so I need my shading. Now, greater than means I shade above this line. So when I look here, here's a point. Above means this section on top. Okay, so again, draw these lines here. Take some time with your shading. Okay, the neater your shading is, the easier it's going to be when it comes to like identifying solutions. Okay, now my last step is to add in this giant S here to indicate this is my solution space where the two regions overlap. Okay, now let's look at this question here. It asks here about a specific point. So is 4, 2 a solution to the system? First off, let's graph it. Okay, so where is that point? 1, 2, 3, 4, 1, 2. Okay, now 4, 2 looks to be a solution, right? So I say, yes, this is a solution. Because it lies within the shaded region of both inequalities. Now, again, if I wanted a more algebraic proof to show that this was in fact a solution, is that would just involve taking my x value of 4 and the y value of 2, substituting it in to show that I end up with a true statement. So 2 times 4 is 8 minus 2, that is in fact 6, which is bigger than 4. And same thing here. If I stick a 4 in for x, a 2 in for y, I've got 4 plus 6, which is 10, which is of course greater than 6. So I can see that also works for the second inequality here. Now again, either solution method works, depends on how comfortable you're feeling. Okay. But that's everything that you need in order to, number one, graph the system, and then number two, verify if a point is a solution or not.